Hello, I'm Gilles Bailet. I'm lecturer at the University of Glasgow in Space Technologies, and I'm the principal investigator for the Pigmented Space Pioneers. We started the project with a really small pot of money from the Impact Acceleration account from the University of Glasgow to investigate how to put my technology into the fashion garments of Katie Tobing. We wanted to bring space engineering, microbiology, and artists together to try to do some outreach in a different manner. But on the way to that, we actually invented a brilliant new technology, first of a kind, that is allowing us to have a two-dimensional dosimeter. You could cover full spacesuits with this fabric, and that will actually measure the radiation, not just on one point like it's done now, but on the full body. And also direct visual feedback for the astronauts to understand what dose of radiation they've been exposed to. And that really leads us also to applications on Earth for the staff at NHS in healthcare, but also for workers in the nuclear industry. The project is centered around the fact that small bacteria produces pigments to protect themselves against radiation.
My name is Keira. I'm the General and Lab Manager at an organisation called ASCUS Arts and Science, and my role in this project is to serve as a microbiologist, growing bacteria to impregnate the textiles that will eventually end up on the spacecraft. Part of the work that we do is pigmented bacteria that is used to dye textiles in a more sustainable way. So instead of using synthetic dyes that contaminate water streams, bacteria can be used as a natural alternative. The same way humans produce melanin or different types of proteins that make our hair curly or straight, bacteria can produce these compounds that then create this pigment. So, for example, an orange bacteria has keratin. Carrots also have keratin. It's what makes them orange. So it's a chemical compound that the bacteria produces, and that is the color that we're using.
You can stack that up, so you will have different layers with different painting for each layer. And when you expose all of that to outer space, this will be bleached by radiation, cosmic radiation, X-ray, UV. And so the layers will bleach one by one, revealing the layers below. And so if you're taking a time lapse of it, you will be able to see color fading, shape changing, everything like that.
My name is Katie Tobing, and I have a background in fashion design with the focus on material experimentation and finding new materials to make garments with. So I'm working on creating the design of the colors of the bacteria on the fabric, and especially the fading element, because the more fade we get, the more we can understand the effect of the radiation on the bacteria. What I want is a result which is visually interesting. I don't want to say beautiful, but visually interesting, but also functional and useful, so we get some data from it. And that's what I'm really trying to balance.
We are working with a startup in Edinburgh called Spinning Around. They are hosting this experiment with us. And so the idea is that we're going to send this brick like that. Everything will be mushed together inside the rocket. It's going to be in space in February 2026 and released for its own mission in March 2026. And so once it will be released by itself, this bit here will be deployed, and we will have a camera inside the main part of the spacecraft imaging our fabric made with pigments. And the idea is if we are able to get good enough data on this mission, then we'll be able to send a larger sample, a larger experiment on the surface of the moon to prepare the exploration of the moon by the new astronauts. This is really possible thanks to this amazing bioprinter, which is here at the Mechanobiology facility at the Advanced Research Center, which is hosted by Professor Massimo Vassalli and Dr. Vinita Jayawarna. This is not just a crazy space scientist in his lab. This is actually a lot of people, from technicians to lawyers and a lot of different people involved. So I'm really grateful for the fantastic support that the University of Glasgow gives me to actually push to the world the brilliant technology that we are developing in the lab.